Hi roboticist! Today we are going to simulate our Universal Robot 5 in Gazebo, and we are going to control it with MoveIt. And finally, stay with me to the end of this video because we will run an inverse kinematics algorithm with C++. Make sure to subscribe to the channel if you like this kind of video, and don't forget the chance to reach me out if you need one-to-one discussion with me regarding your problem in your robotics application, or in general if you want to become a robotics software engineer. Don't worry, it will be totally free. And now let's get started. Okay, so in the last video we have understood how to install the Universal Robots package from GitHub, and we have already seen what there's gonna be inside. And so today what I'm gonna do, I'm going to teach you a method to simulate any kind of robot that you can download from GitHub, and I'm trying to give you a structure method to do that you can use in whatever robot you want to simulate, no matter the complexity of the URDF file. So it's going to be an intuitive method. Okay, so what we can do for the moment is to create, let's say, another package to simulate this robot. Why we are doing that? Because if you run the Universal Robot Gazebo launch file, UR5 bring up launch file, you're gonna see that it doesn't work, or better, the controllers of the joint are not spawned correctly. So it's better that I would suggest you to follow this structure method. I hope that you appreciate that. So that's why I would suggest you to create another package. So let's go in our cutting workspace. And then let's put the dependencies here. Okay, the package has been built correctly. So in general, if you want to simulate a robot, what you will need to do is create a launch file in your robot application, and in this case it will be our UR app YouTube package that has the following feature. The first is going to be the URDF, which is going to be a parameter of your robot description. Then second, you need to spawn your robot into Gazebo, or if in Gazebo, or if you have a word to simulate your industrial environment. Then the third point will be to spawn your ROS controllers. So we're gonna use the controller manager. And then we will need to interface with the MoveIt. So we will need to create the MoveIt interface. So the scope of this video is to create this launch file, but first let's do it step by step. So imagine that you have a very complex robot like UR5. So a method to get the URDF file if in your robotic application, since that here is very complicated because your description has a lot of configurations, limits, kinematics, meshes, etc. A good method would be, for example, to copy the UR file generated from the UR5 MoveIt config. So what's I'm telling you, you're gonna discover in a while. So let's launch ros launch the MoveIt setup assistant. Okay, then let's edit a file. We will not going to edit, but we just need to copy the simulation here. You're gonna see. So let's get this package. Here we are. This is our robot. We are not touching nothing. Remember that this is manipulator and this is the base, and the tool 0 is the name of the link of our end effector. Very important. We have seen in the last video. I'm gonna put the link of the video on the top right corner. So the poses is gonna have the home and the up, and the effector we don't have for the moment, passive joint. Okay, important. This is gonna be of type follow joint trajectory, and the name here suggests us that the hardware interface of the joint will be effort type, but we're gonna see in a while. Then this is what is very important. So what we're gonna do is to copy everything here, and we are gonna copy in the file that we are going to create inside a URDF folder. So in our URDF folder, we're gonna create a file and we can call it UR5 YouTube chakra file. Okay, here we go. This is our URDF file. We can see here that the name is gonna be URF underscore robots. Okay, so we will need to make some modification here. And the first thing, something that I really suggest you, is to give a namespace here. This will be very important because if you have several robots in your application and you don't have a namespace for each robot, then you can imagine that the simulation will be difficult to run, and then you can have different robot for different controllers. So we are gonna call it UR5. And then what we will need to add here will be the ROS Gazebo ROS control libraries, which is this one. Okay, then an important thing to do is to change the hardware interface to an effort joint interface. So let's do it for all the joint. Okay, it's done. So another thing that we will need to do, this is the base link, the inertia value, okay. What we will need to do is to fix the base link to the word. Otherwise, when you run into the simulation, it's going to act crazy because it's not fixed anywhere. So let's add the link word here and create a fixed joint with the parent word and the child base link. Here we go. Okay, so a good practice at this point, in my opinion, will be to create an RV's launch file where we are gonna spawn our robot in RV's. So we are gonna go into our package. We will need to create a launch folder, and then let's create a launch file called RV's UR5 launch. Okay, this is the basic launch file. So let's run it. And this is a good practice in order to make some confidence with your robot, so you can play with the joint. Okay, this is normal because we don't have the robot model. Let's add it, robot model. Here we go. Okay, you can play with the joint in order to make some confidence. Here we go. Okay, it's working. Okay, so let's save this configuration. So now if we comment this out, and we uncomment this, the next time the configuration will be loaded automatically. Okay, so to make sure that the configuration will be loaded correctly in RVs, let's launch again the RVs. Okay, the configuration has been loaded correctly. With the joint state publisher GUI. Okay, feel free to play with the joins in order to make some confidence with the type of joint that you have in your Universal Robot 5. It's always as good practice to take some confidence with the joint of an external package, so you can realize what are the limits of each joint, and so on and so forth. Okay, the objective here is also to spawn the robot in Gazebo. And as of now, the key thing that we need to do is to use the controller manager. And to do that, we need to configure our ROS control for our. So what we need to do is to use the controller manager in order to load and configure the controllers of our joints. So in order to do that, let's go inside the configuration folder of our package, and let's create another file, and let's call it UR5. We are gonna set up effort controllers. Dot YAML file. Okay, so the point here is what we need to check here is what is the type of the hardware interface. So as I said, we have set up effort join interface as a hardware interface. So before to write any code here, we need to know that the type of controller for the hardware side will be effort controller. So remember that if you are gonna use an effort controller to control the hardware, you will need to tune the PID. We are not gonna do that. Why that? Because the creator of a Universal Robot package has already think about it. And if we go in the Universal Robots package that you have downloaded and installed last time, go inside the UR Gazebo, which is responsible for the simulation, go in config, and then here we're gonna have the UR5 controllers. So here what we are gonna do is just to make a copy and paste. Okay, here we are. We're gonna use as hardware interface effort controller, and here are the values of our proportional, differentiate, derivative, and integer value of each joint. So I'm not gonna touch it, and I will suggest you to do not do it. And here the name of our joints. There's something that and we are gonna use a joint trajectory controller as software. Because you're gonna use the MoveIt plugin that uses joint trajectory controller. Okay, if you're gonna spawn these controllers in Gazebo, it's not gonna work. Why it's not gonna work? Because in our chakra file we have named a namespace UR5. Okay, so the most important thing is to assign to this group of controller the namespace UR5. And how to do that? Well, it's gonna be very simple. We just need to add on top of this the namespace UR5. UR5, that's all. That's everything that you need to do. This joint state controller and the effort joint trudge underscore controller will be the controllers inside the namespace UR5. And so if for example you're gonna have another robot in your application, you will need to assign to this controller the new namespace. Okay, so now with this namespace you are sure that these controllers are assigned to this chakra file. Okay, the next step that we will need to do is to create our MoveIt configuration package, and this is something that we have done multiple times, but let's do it again from scratch with this UR5. But anyway, the same package you're gonna find it in the Universal Robot package, then UR5 MoveIt config. And so let's ROS launch MoveIt setup assistant. Okay, now create a new package. Let's load the chakra file that we have created. And planning group. Okay, so let's call it manipulator. This is how the original one is called. Let's use this kinematic solver. Let's add the joint. The joint should be 1, 2, 3, 4, 5, 6. That's it. Let's add also the link. And let's add a tool 0 where the end effector will be attached. Okay, we don't have an end effector for the moment, so we don't need to add anything. So robot pose, let's add the default one that is gonna be 0. Okay, let's save it. Then also add a pose that is gonna be the up position. What is gonna do is gonna be minus 90 degrees. That in Radian is gonna be minus 1.57, and then let's probably it's gonna be this one. No. Here we go. Okay, save it, and the effector we are not gonna have. Passive join not. Controllers, well, yes, but I would prefer to add it manually. You're gonna see in a while. Simulation, 3D perception, okay, author. Let's generate the package. Okay, done. Okay, so this is the package that has been generated. So first of all, before to use it right away, let's add the controllers here. Here you are. This is the name of the controller that is gonna be UR5 with the namespace. I remember you remember this one. Okay, this is UR5 namespace for joint interface where we are gonna attribute as software interface the follow joint trajectory action namespace, which is of type follow joint trajectory, and then all the joints that we have seen before. So this is the controllers for MoveIt, and this is the controller for Gazebo, and that the controller manager loads. Okay, now we need to create another package, another file here in the launch file, which is gonna be UR5 robots. Here we go. We need to launch the ROS controller YAM file in our MoveIt configuration file. And now we should have everything to create our launch file that contains, I remember, the URDF, our robot spawned in Gazebo, then the ROS controller, and the MoveIt configuration package. Let's clean this up. Okay, so we need to work in our package. So in the launch file, create a launch file called spawn UR5 with the effort controller launch. Okay, so let's start to populate the last piece of our interface of UR5 in Gazebo and controlled by MoveIt. Okay, first of all, we are gonna load our chakra file and attribute as a parameter in the robot description. Okay, then second step will be to spawn our robots in Gazebo. Okay, here we are. We set the position of the base link where it's gonna need to be spawned. Then we load the empty world here. Okay, this I have commented out. This is you should already know this package, but I have commented out here and here, so the robots will be spawned in an empty world. And then, well, yes, we are gonna spawn the package using. You're gonna spawn the robot using the package Gazebo ROS. Okay. Now it's time for loading our ROS control, and with the help of the controller manager. And here you are. We need to spawn our configuration YAM file, which is this one, the effort controller, and then we are gonna call the node controller manager with this namespace. Really remember you, otherwise the controllers will not be loaded correctly. And then we need to remap the joint states to the namespace UR5. We need to do it for the robot state publisher and the joint state publisher. Now, last thing that we need to do is to load the MoveIt configuration package. Okay, here we go. Now we should have everything. So let's build our package first. Okay, this is built correctly, so now the only things left is to test everything. Okay, I have loaded my environment in pause. Okay, here are our robots. Okay, the robot here is spawned 0.5 meters in Z direction. Let's test the robot to go in the upper position. Let's plan and execute. Okay, it's working very good. Okay, now an important thing that we can do is to ask the robot to go in a certain position. So, for example, ros run, we transform echo base link and tool 0. I have talked about this in the last video. I'm gonna put the link in the top right corner. Okay, so this is the position of the end effector related to the base link, which is very useful if we want to ask our end effector to reach a certain position. Okay, for example, just move it in this direction here. Okay, this is executed. Okay, let's check where the end effector is. Okay, so we can see here that the end effector has this orientation and this position related to the base link. So let's put this value in our inverse kinematics algorithm that is gonna be here. I have prepared already this from the last time. Okay, let's check it. Remember this position here. Let's simulate again. Okay, and then let's ask to go in the position that we have set up before in our inverse kinematics algorithm. ROS run, let's run that node. Cobot inverse kinematics, then let's check it. And here we go. He's moving in the position that we asked it to go. Okay, that's all for today. I hope that you enjoyed this video. As a wrap up, we have simulated our Universal Robot 5 in Gazebo, controlled with the MoveIt plugin with RVs. And we have gone all through the process for creating the launch file, and in general I remember you that you need to create your URDF file that spawn your robot in Gazebo. Let's start as keep it simple in empty Word. Then you're gonna make some modification in the URDF file, because you need to get your namespace of your robot, very important. Then make sure that all the hardware interface is gonna be effort controller, for sure, if you want to use a effort controller as another interface, and then make sure that the ROS control for Gazebo plugin is loaded correctly. Then you need to create configure your controllers that allows your controller manager to spawn the controller for your joints. And finally, you need to create a MoveIt configuration package and have some modification, especially in the ROS control for the part of the software. And in this particular case, we have used as a software interface the joint trajectory controller. Again, in this channel, Learn Robotics with ROS, the mission is to help you in being a robotics software engineer, and I'm gonna teach you the best as I can to program robots with ROS, and in particular for industrial application. So if if you need some suggestion or a free let's say consultancies on your robotic application, feel free to reach me out by via email, and I will be happy to know your what you think about this kind of content, and I will be happy to help you out in your journey for being a robotics software engineer. Again, thanks for your attention, and as always, keep learning robotics with ROS.